Welcome to Explore Science with the Ward Beecher Planetarium. I'm Tiffany Woolbrick, and today we will be doing real science that you can do along with us at home. For the first part of our video, all you'll need is a big tub of water like this and some random objects that you find in your home. Just pick up any old object that you think is interesting. We will be exploring the property of density. Why is it that some things float in water while others sink? This all can be explained with density. Density is simply how much mass something has compared to its size, its volume. And so for objects that are really small, like this paper clip, but made out of a kind of a heavy material like metal, this is going to be more dense than water. So it sinks straight to the bottom. For objects that are a little bit bigger, like my sponge rubber ducky, but doesn't weigh a lot, right? This is very, very light. This is going to be less dense than water. So what's going to happen? It floats. Yes, so objects that float are less dense than water, and objects that sink are more dense than water. And because water is so important to us in our daily lives, it's a really great way to compare densities of materials. In fact, this is how we've first come to learn and understand about what density is by comparing it to the density of water. So let's do a couple of items. I have a button here, just a little plastic button. Now, this becomes the fun part of science, the hypothesis, where you get to guess, you get to make guesses. Do you think this is going to sink? Or do you think it's going to float? Is it less dense than water or more dense than water? Let's find out. Our button is more dense than water. We can see it in the bottom there. Okay, what about this apple? We know how heavy an apple feels in our hand. It feels kind of heavy, right? Is it more or less dense than water? Make a guess. Let's find out. Oh, it made a big splash, but it popped right back up because it is ultimately less dense than water. So yes, even big objects can float. For example, the planet Saturn is less dense than water, which means if you had a tub bigger than Saturn and you put the planet inside, it would float in the water. Isn't that amazing? Okay, last object, just because this is fun. This is a little toy metal car. Is it going to float or sink? Is it more or less dense than the water? Let's find out. Oh, it sunk straight to the bottom. That would probably happen with a real car too, huh? Okay, well, this was fun. So we learned a lot about what density is in comparison to water. But what about other liquids? What about the density of other liquids that's not water? Let's find out. All right, to test the density of different liquids, we just find some different kinds of liquids around our house. First, I have water in my little bottle here, just so that we can compare the other liquids to the water. I have syrup. This is light corn syrup, but you can use the brown syrup that you put on your pancakes. And I also have oil. This is canola oil. You can use vegetable oil, olive oil, anything you'd like. Okay, to get started, I'm going to put a little food coloring in our water because it's fun and it'll make our water really stand out. Make that mix around. A nice blue water. Okay, next we're going to add syrup. What do you predict the density of the syrup will be? Is it going to mix up with the water? What's going to happen here? Let's find out. So what happened here? The syrup, it sank to the bottom. It is below our water, and the water is sitting on top. So what we can say about density with this is that the density of water is less than the density of syrup. Syrup has more density, so it sinks to the bottom and it separates out. Let's try a different liquid. Let's try oil. You think its density is going to be more or less than these other two liquids? Let's find out. Oh, it looks like it's mixing up a little bit with the water, creating sort of a lava lamp effect. It's settling out though and separating on top of the water. So we have 3 different liquids here with 3 different densities, and that's what creates this really neat layering effect in our bottle. Now this is a fun part. Find some random objects in your home that you can test in the bottle of different liquids you have here. I have a nut, I have some raisins, and a little plastic cap. But really you can try any small object just to test and see what their densities are. We can compare the density of these objects to the densities of the liquids in this bottle. So this is a nut. It's probably made of steel or some heavy metal. Let's see what happens when we drop it in. Oh, it sinks straight to the bottom. It's even more dense than our syrup. Okay, well, what about our raisins? You can use a grape with this too, or anything you find in your house. Oh, it's sinking. There it goes. It looks like it got caught on the layer between the oil and the water, and then it sat there for a moment, and then it sunk straight to the bottom, and we can see it resting on top of the syrup. So it is more dense than water, but less dense than syrup. Raisins are more dense than water, but less dense than syrup. Pretty cool. Okay, this is a plastic top. You can also use like a top from a water bottle or anything like that. We'll pop this in. It's sort of floating on the oil, but I think it's because the cap hasn't filled up. Let's see what happens when you fill the cap up. Oh, it sunk. And now it's resting on top of our oil. So it is less dense than water. This cap would float on top of water, but it's more dense than our oil, so it sinks in our oil. And that's another interesting thing, is that the cap floated before it had oil put inside of the cap itself. And that can affect the overall density of an object. That can sometimes help things float. So then I have the last object I have here is just a little piece of sponge. It's very, very light. So we can see that just sort of rests there on the top. Even if I kind of poke it a little bit, it's still very much floating on the top of our oil. So there we go. We have lots of layers of different densities in our liquids, and we can compare the density of solids to the densities of these liquids with this really simple experiment. This is another very simple experiment where we can explore density with water. All you need is 2 glasses that are the same size and fill them up about equal level of water. You only need 2 other ingredients. One is eggs, and the other is a secret that I'll show you in just a moment. So we have 2 eggs. They're uncooked, straight out of the carton. We're going to put them in the water. I think you need... Okay. There we go. And so they both sink. They're both more dense than water. Our secret ingredient is some table salt. So the only thing that I'm going to do differently, I'm going to keep this one exactly the same with fresh tap water and our egg at the bottom, but I'm going to add salt to the other one. Let's see what happens. Let's mix, 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 mix. All right, and now that our salt has settled a bit and our water is not quite so cloudy, we can see that the egg in our salt water has risen to the top, while our egg in our fresh water remains at the bottom. What we've done here with our one special simple ingredient of table salt is we've turned fresh water into salt water, which is more dense, and it is now more dense than the egg. So the egg will then float to the top. Now we've explored density. Using just a few random objects from our homes, we can explore this incredibly important property of matter that helps us in all areas of science. Even astronomers use density to help us understand the universe, from neutron stars to dark matter, and even exoplanets, planets that orbit other stars out there in the night sky. Those planets are so far away and so hard to observe, but we can detect their density and use that to guess if they're going to be a really big gas giant like Jupiter or Saturn, or if they'd be a smaller rocky planet like Earth. Thanks for joining us today. If you have any comments or questions, please let us know in the comment section below. We would be happy to engage with you further on topics of density, of all things density. And until next time, keep exploring.